so the last time we were discussing naming ionic compounds, we talked about the naming of binary ionic compounds, and then we talked about naming ionic compounds containing polyatomic ions. Now we're going to get into a discussion of naming binary molecular compounds. So molecular compounds are basically compounds formed from non-metallic elements, right? And therefore, as a result, we're talking about compounds that are not ionic. So we'll be focused on naming these particular types of compounds. Now, in such a compound, the rule of thumb is that when we're naming binary molecular compounds, that the element that is farthest down and to the left of the periodic table is the one that is usually written first. In other words, we're talking about the element that is more metallic in nature, all right? So what you do if you're dealing with a binary molecular compound, when you're naming them, you look at both elements and you look at the one that is furthest down and to the left of the periodic table, and that one will be indicated first in the name as well as in the formula, all right? So that's something you have to take into account. Another thing you have to do, and this is one marked difference between naming ionic compounds and molecular compounds, is that we have to use prefixes to indicate the number of atoms of each element present in the molecule. Now, the prefix we use is a Greek prefix which is placed before the name of each element to indicate that number, all right? Now, there's an exception. In fact, there are a couple of exceptions, but the one that I'm going to mention here is that if there's only one atom of the first element in the formula, then we use no prefixes. And we're going to see some examples of that shortly, all right? So these are the prefixes here, the Greek prefixes that we use when we're naming binary molecular compounds: mono for 1, di for 2, tri for 3, etc., all the way down to 10. For 10 we use deca. And there are some others, but for all purposes, that's where we're going to stop at 10, all right? So these are the prefixes that we have to be accustomed to using when we're naming binary molecular compounds. And again, let me stress here that the prefix mono is very rarely used, in fact, not used at all, if there's only one atom of the element that is mentioned first in the name or the formula, all right? So here are some examples. So let's take this one, N2O3. So let's say you're given the task of naming this compound, all right? So what we do is that we identify the first element, which is nitrogen, and there are two of them, 2 nitrogen atoms in the formula. And the second element is oxygen, 3 of them, all right? And then basically we have to put them together. And the way we do that is that we say dinitrogen. The di indicates that there are 2 nitrogen atoms. And then we say tri for the 3 oxygen atoms. But you'll notice that we use the IDE ending, all right? This is similar to what we learned when we talk about binary ionic compounds. The second element, we use the stem of the name of the second element followed by the IDE ending, and therefore the name of this compound is dinitrogen trioxide, all right? Okay, here's another one. Now this one, you'll notice that we have 1 phosphorus atom to begin with, followed by 5 chlorine atoms, right? So therefore, if you remember, we said that if the first element mentioned in the formula has only 1 atom in the molecule, then we do not use any prefixes for it, so we cannot use mono, right? However, we have 5 chlorine atoms, that's the second element, so we would use the penta prefix as far as the chlorine is concerned. So therefore, the name of this compound is phosphorus pentachloride. Phosphorus pentachloride, all right? Okay, not monophosphorus pentachloride because of what I said before, right? Because we have only 1 atom of phosphorus, and that atom is the first one indicated in the formula. All right, in this case, Cl2O7, right, we have 2 chlorine atoms, right? So therefore, the di prefix would be applicable here, and we have 7 oxygen atoms, so the hepta prefix would be applicable as far as that is concerned. So therefore, the name of this compound is dichlorine heptoxide. In some textbooks, you'll see heptoxide, in other words, no A here. That is allowable according to IUPAC. Or if you want to call it heptaoxide, that's fine as well. All right, so that's the name of that compound. Okay, here are some other examples. So the name of this compound here would be dichlorotrioxide, or dichlorine, I should say, trioxide, because you have 2 chlorine atoms and 3 oxygen atoms. All right, so the di comes from the 2 chlorine atoms, and the tri comes from the subscript 3 for the oxygen, and that's the name of that compound. Now in this case here, we have only 1 carbon atom, so therefore we would not use mono, and we have 4 chlorine atoms, so tetra would be the prefix associated with the chlorine atom, so therefore the name of this compound is carbon tetrachloride. All right, and then this next example, CO, right? The first element is carbon. There's only 1 of them, so no mono. But for oxygen, it's a second element, so we have to use mono as a prefix for that element. So the name of this compound is carbon monoxide. All right. And in this case, this one is called carbon dioxide. All right, because you have 2 oxygen atoms present per molecule. All right. And here's a third one, or here's the next one, I should say. Pi3, no prefixes for the phosphorus. There are 3 iodines, so the prefix here would be tri. So the name of this compound is phosphorus triiodide. All right. Okay, so that's it for this. Now the next video we will be dealing with acids. All right. So until next time.